So hello everybody, my name is Abhineet Dhara and today what I have made is an AC live current detector. So what this does is this is my contraption, and what this identifies is if there is any live AC current going through a particular wire. So now I will show you how this actually works and let's test it. Now let's see, and let's test it how this will work. So I have my contraption right here, and this is a wire of my laptop charger, and this is connected to the plug, and the switch is off right now. So what I'm going to do is I'm going to take my tester and I'm just going to wrap it around the wire. First you see that there is no light blinking, no light glowing. Now we will see what will happen when I turn on the switch. If it doesn't work on the first try, you can just recheck the switch. Yeah, if you see here, when the electricity is flowing from here, the light is on. When I turn off the switch, the light goes off. When I turn on, the light comes back. When I switch off, the light goes off. So this is how it detects AC current flowing, live AC current flowing through. As if I turn it off, it doesn't glow. That means there is no AC current flowing through here anymore. When I turn it on, it glows. What is exactly my contraption made up of? My contraption is made up of, you can see this is a battery pack with the wires. Then there is this LED, and here are the two transistors which I am using. Now the transistors which I am using it's BC475 transistors. I don't know if you can see it or not, but these are the two transistors which I am using, and then there is a LED connected to it, and the main part, which is this wire which is coming from one end of a transistor. This is nothing but a copper wire, and what I did is I just burnt off the excess enamel which was coating this copper wire. So this is how I made my contraption, and now I'll explain how does this actually work. How does this work is this wire which you can see here is not just acting as a wire, but this is acting as a capacitor, which in turn helps to take in the voltage. How, I will tell you that later, but for now this wire is acting as a capacitor. So that means if we increase the surface area of this wire, then it will work much better. Now let me show you how this actually, what is the reason behind this of taking in the voltage. If you can see the diagram, the AC voltage, the current which is coming is in reference to the earth, and the earth has a straight capacitance between the earth to the circuit, or from the human body to the circuit. Means the capacitance from the earth to human body to the circuit, or either from the environment of the earth to the detector circuit. And this detector, this wire which I attached with the transistor is a copper wire, and this has some capacitance with the live wire which was carrying the AC current, and in turn there is again some capacitance right there. So with all these capacitance added together, the circuit becomes closed, and because of that closed circuit, this wire can take in the voltage from this live covered wire, and because of that taking in of voltage, the light bulb can glow. Now, many people might also be asking that if my copper wire does everything, then why do we need transistors to power the light? Now we need transistors to power the light because the copper wire which takes in the voltage is very low, which cannot turn on the light. But because of our transistors, what does transistor do? Transistors take the energy signals and it amplifies it. It makes it much more vibrant. What will I say? It amplifies that electrical signal, and because of that I have used two transistors. This transistor amplifies the signal, and this transistor amplifies the amplified signal more, and because of that my LED starts glowing.